Okay, this is our second lesson in sequences and series. We know what a sequence is, an ordered list of numbers, and now we learn what a series is. So a series is the sum of a sequence. So here's some sequences on the left, right? An ordered list of numbers. And the associated series would just be replace all the commas with pluses. 6 plus 9 plus 12 plus 15. Also, notice here, 3, 7, 11, 15, dot, dot, dot. Okay, what does the dot, dot, dot mean? Right, the dot, dot, dot means it's infinite. It means that goes on forever. Just keep following the same pattern that you did to get to that second, third, and fourth term. Just keep it going, right? It's infinite. So the infinite series would be 3 plus 7 plus 11 plus 15 plus. Now, you can see this is clearly an arithmetic sequence that we're adding up. And you know that every time you add another number, it changes the sum. If it's a finite series, meaning the sum of a finite sequence, actually that's something you could evaluate. You can just add them up. So when we say to evaluate a series, it means just find the sum if you can. Of course, if it's an infinite arithmetic series, you won't be able to do that. So we have a formula. If you did the copy work that I assigned for extra credit before this unit, you would have already copied this. This is the formula for the sum of a finite arithmetic series. You can see that we introduced this notation here, which is a capital S with a subscript of n, which stands for the sum of n terms. And you can see that the formula is n, which is going to be the number of terms, and it's the number of terms. A1, we know already, that means the first term. And an, which, again, the an will depend on how many terms that you've got. So, I mean, if we're saying that find S10, then an is probably A10, the 10th term. Although it could be a little trickier than that. Sometimes we'll refer to this, instead of just saying that it's the nth term, we're going to say that it's the last term. So let's see an example of how we use this formula. So it says, what is the sum of the even integers from 2 to 100? Now this is probably not exactly the question you might get on an SAT test, but it's kind of like a question you might get in an SAT test. Definitely, they would think that you are very aware of what it means when they say find the sum, that we're looking for even numbers, and we're actually looking for even integers. I mean, all of those are words that we're just expected to know by now. So let's see, what is the sum of the even integers from 2 to 100? Okay, so that's saying what is 2 plus 4 plus 6 plus dot, 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 plus 96 plus 98 plus 100. So leaving out all the terms in between 6 and 96, it's the sum of all those numbers. All right, so let's see our formula, how it applies to this. Sn equals n over 2 times a1 plus an. Again, the n is the number of terms. That actually might be one of the trickier things to figure out here. But n equals the number of terms, right? How many even numbers are there between 2 and 100? And If I said how many numbers are there between 1 and 100, you would definitely say 100. So how many of them are even? That's 50. And what is the first term? We need that for here. Well, luckily we can see that right there. That's 2. And what is the last term? In this case, the last term is A50, which is 100. We can see it right there because we wrote it. So those are all the inputs to this formula. So we're going to say S50 equals 50 over 2 times 2 plus 100. So S50 equals 25 times 102. Okay, and so that's something you can put in your calculator. So let's see, if I did 25 times 100, I would get 2,500. Then I would have another 2 times 25, so 2,550. You can do that with your calculator if you want to verify that. 2,550. So there's a story of a famous mathematician, Gauss. He was a German mathematician. Some say he's the most prolific, meaning he produced the most important work of any mathematician in history. And there's the story of him being such a precocious youth that at a very early age, when kids had just barely learned how to add, his teacher in Germany said, I want you to find the sum of all the numbers, or let's say just it's this problem, all the even numbers between 2 and 100. And of course, the teacher is thinking the kids are going to start adding. 2 plus 4 is 6, 6 plus 6 is 12, and keep going and going and going. That this is an activity that's going to keep them busy for a long time. Okay, but somehow this Gauss kid, at a very young age, he figures out that in fact, if I add the first term and the last term, right, I get 102. If I add the second term and the second to the last term, I get 102. If I add the third term and the third to last term, I get 102. So what do you notice? Every time you add this pair of numbers, you get 102. Now, how many pairs of numbers are you going to get? Well, there was a total of 50 numbers in the string, in the series, so there's going to be half that many. So that's where this 50 over 2 comes from. There's going to be 25 of those, 25 102s. So somehow, at a very early age, this guy, Gauss, had figured that out. So try to do the same thing with this. Use the formula. I've given you the number of terms here. Again, this is where you are supposed to hit pause and actually try to do this. If you just let the video play and copy what I did, and your work looks exactly like my work, I know you're not really trying this. You're just going through the motions to get your 2 points, which we all understand, but you're not going to learn this unless you actually try it on your own, right? Look at the last example and how it worked. This one will work the same. So again, hit pause, and when you've tried it, hit play. So again, I'm going to write down my formula because I always write down my formulas before I fill them in with values. Okay, so that n is given. The first term is visible. The last term is visible. This is an, right, which is going to be A20 because it's 20 terms. And so I'll fill everything in here. S20 equals n over 2 will be 20 over 2. First term is 4. Last term is 99. Right? At that point, this is just a plug and chug, maybe even a calculator exercise, right? So 20 over 2 is 10. 4 plus 99 is 103. 10 times 103 is 1,030. Okay, so we can represent sums, series, with a notation which will be new to you, but it is actually something you need to understand because it shows up a lot in mathematics. Okay, so this notation is called either summation notation because it represents a sum, or it may be called sigma notation because this symbol right here is the Greek letter, capital letter, sigma. Okay, and you can notice that there's a bunch of parts to this thing here. Right? Always on the bottom, you're going to, whatever your variable is that you're using, and it's usually n, but it's not always n. Sometimes it's I, sometimes it's k, sometimes it's j. It can be anything, but usually it's n, right? Equals some lower limit. This is going to be the first number that we use as we generate our series. And then on top of the sigma will be what they call the upper limit, 108. Okay? In front of the sigma, to the right of the sigma, that's a formula for the nth term of the sequence. Right here they say this is the explicit formula. Okay, well we know what that means from our last lesson. That means this is an an, right? It's an a sub n. So that's what a summation or sigma notation looks like. What it means is like this. So this one here would equal, all right, first I would plug in 3 to this formula, n squared, and I would get 3 squared. Okay. Then I would plug in 4, right, add 1, plug it in, 4 squared. Right. Then I would plug in 5. You see the pattern. And I would keep going until I get to 108, right? So plus 108 squared. Right? That's how a sigma or summation notation represents a sum. So what is the summation notation for the series? Okay, so first, we know the parts of this thing here. I've got to have a summation. It's going to say n equals. Now, if you have to come up with this on your own, then you probably, most of the time, just want to say n equals 1 is going to be my starting point. Okay. Now, how many terms is there going to be? Well, that'll be the number on the top. We're not ready for that yet. We need to come up with our formula here for the a sub n. Well, look at our numbers. Look at our numbers here. The numbers go from -5 to +2 to +9 to +16. You know, we recognize this. This is an arithmetic sequence or an arithmetic series. So we know how to come up with that explicit formula. It's an equals a1 plus n minus 1 times the common difference of d. And we've got everything we need here, right? The an, the first term was -5. Remember, you don't replace n at this point. The d looks like it's 7 because we keep increasing by 7. I can simplify that. -5 plus 7n minus 7. So an equals 7n minus 12. Now I'm going to check it to make sure it works. If I plug in 1, I get 7 minus 12, which is -5. If I plug in 2, I'm going to get 7 times 2 is 14 minus 12, which is 2. So it looks like it works. Okay, so this is my formula here is 7n minus 12. And what goes on the top? What goes on the top is going to be whatever gets us to that 268, which is the last term. Okay, well, in order to figure that out, I'm going to say 268 equals 7n minus 12. Let's figure out the n that generates the value of 268. Add 12, get 280 equals 7n. Divide by 7, n equals 40. Okay, try to do the same thing with this. So we're going to start. It's the sum of, from n equals 1 to whatever. We can see that we have an arithmetic again. It looks like we keep adding negative 10 to get to the next term. Right? So again, d equals negative 10. That's what happens if numbers are going down, then the d has to be negative. We have the a1 is right there. So we have everything we need to plug into this formula. So an equals 500. And to say this is a place where we make a lot of mistakes. So I'm going to say plus n minus 1. And I'm going to make sure I put this in parentheses, the negative 10. You know, you got to see this for what it is. This is a distributive. You're supposed to be multiplying like this. It's not like saying n minus 1 minus 10. I get that a lot. If it makes it easier, you could go 500 plus negative 10 times n minus 1. Maybe if you saw it on the left, you might be more likely to see it for what it is. It's a distributive property thing. In any case, I'm going to get an equals 500 minus 10n plus 10. So an equals negative 10n plus 510. Okay, now let's make sure that this works. Let's plug in a couple values of n. Okay, if n equals 1, then I get negative 10 plus 510, which is 500. If n equals 2, I get negative 20 plus 510, which is 490. So it works. It's giving us the right terms. So I've got negative 10n plus 510. The only thing left is to know, well, how many terms do I have in this thing? Again, figure that out. We want to know which term in the sequence is this. So let's plug in 10 for an and solve. Right, subtract 510 to the other side. We're going to get negative 500 equals negative 10n. Divide by negative 10, and it looks like n equals 50. So we're going to go from n equals 1, the lower limit, to n equals 50, the upper limit, the sum of the terms generated by that sequence. Okay, here's your U-try. So again, you can go to hit pause and actually try it. And when you're done trying, then hit play. So this is one we could do just like I did the last two, and we could come up with the right answer. Another thing you could do is, since you've got these 4 to look at, right, you could just like try it out. It should be, when you plug in the lower limit, you get the first term. Okay, so let's see. The first one, I would get 4 times 1 plus 3, which is 7. That's good. 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 Okay, they all give us the 7. Okay, let's look for the last term. If I put in the 51, I should get 207. 4 times 51 is 204, plus 3 is 207. That works. Okay, plug in 50. 4 times 50 is 200 plus 3. That's 203. That's not right. Can't be that. Right? 50 times 7 is 350. That can't be right. And 51 times 7 would be 357. That can't be right. So actually, we could tell that it's this one here. But if I'm going to go through the steps like I did on the last slides, again, I'm going to start with my formula. I'm going to say this is the sum of n equals, and I'm choosing to start at 1. Now I'm going to come up with my formula for this sequence. an equals a1 plus n minus 1 times a common difference, which looks like it's 4. an equals 7 plus 4n minus 4. an equals 4n plus 3. So that's the 4n plus 3 that we expected. last, in order to figure what's the upper limit for this summation, let's plug in the last term of 207 and solve for n. Subtract 3. Divide by 4. 51. Okay, so I think I mentioned this in the last one, but you know, when you end up with formulas like an equals 4n plus 3, you know, that kind of looks like y equals mx plus b, which means that arithmetic sequences and series, they should look like they're linear in form. So when you see a summation that has that form for the a sub n, then you know you're talking about arithmetic, which means you're going to be able to use the formula for the sum. Right, so what is the sum of the series written in summation notation? So do we want to generate 70 terms? The answer is no, we don't. We recognize 5n plus 3 kind of looks like it's linear, which means this thing is arithmetic, right? What looks linear, therefore, this is an arithmetic series. Okay, if it's arithmetic, then we can use this formula. Okay, so if we want to use that formula, we need 3 numbers, right? We need to know how many terms are there, what's the first term, and what's the last term. Okay, well, let's see, how many terms are there? If the lower limit is 1 and the upper limit is 70, okay, that's pretty easy, there's 70. Okay, how would we generate the first term? We would plug in 1, 2, n. And we would get 5 times 1 plus 3 equals 8. How would we find the last term? We would plug in the upper limit. Oops. an, which is going to be a70, is going to be 5 times 70 plus 3, which is 350 plus 3, 353. So those are the 3 numbers we need to plug in over here. Sn, actually let me change that, S70, because I know I'm adding up 70 terms, is 70 over 2 times 8 plus 353. So S70 equals 35 times 361. Which I do not know off the top of my head. But what I'm going to do here, let's get the calculator working for us a little bit. Ultimately, when we take Hampton City Schools generated tests like the CSA, then we're going to have to use this calculator. Can't use Desmos. Although Desmos would do all of this stuff too. But we will end up using this calculator. So let's go 35 times 361. And it looks like 12,635. Okay, so what is the sum of this series? Well, again, on the last slide, we could look at the A sub n formula and say, well, looks kind of linear. Okay, this doesn't look linear. This looks quadratic, which means, you know, that formula, Sn, we can't use that. So at this point, the only option we've got is we need to just substitute. Let's just generate the terms, right? We have no other way to find this other than let's plug in 1, then 2, then 3, then 4, then 5, then 6, then 7. Okay, there'd be 7 terms. Right, the first term when we plug in, we'll get 1 minus 1, which is 0 squared. The next term will be 2 minus 1, which is 1 squared. And you can imagine how this is going to go. 2 squared plus 3 squared plus 4 squared plus 5 squared plus the last term should be 7 minus 1, which is 6 squared. And at this point, this is just a brute force calculator exercise. 1 plus 4 plus 9 plus 16 plus 25 plus 36. So let's do that. And the answer is 181. So again, just because it's not arithmetic doesn't mean we couldn't calculate it by generating the terms. Now you would never be asked to do that if this was like 1 to 100. It's always just going to be a few terms and an easy calculation. Right, so let's try to do the same thing with first this one here. So which one of these two looks linear? The answer is this one. So definitely see if you can generate the terms to plug into this formula. So go ahead and hit pause and again go back to the previous, not the last slide, but 2 slides ago and see how we did this. Okay? When you're done, hit play. So it looks like our n is 40. I'm going to do it over here. N equals 40. A1 equals what you get when you plug in the lower limit, -5. AN equals what you get when you plug in the upper limit. 3 times 40 is 120, minus 8 is 112. So plug in those 3 numbers. S40 equals 40 over 2 times -5 plus 112. Now, if you're doing this with your calculator, at this point, you could just put that in the calculator just like it is. You know, you don't have to like show all these intermediate steps. I will. 20 times 107. Okay, which should be, let's see, 2 times 107 should be 214, so it should be 214 with a 0 on the end. Okay, again, try this one, understanding this is not linear, so we're not going to be able to use our formula. Just make 4 terms, right? Plug in 1, 2, 3, 4. Okay, so I don't remember what I last said because I just paused the video, but go ahead and hit pause and try to do this one by generating the 4 terms. Okay, so again, I'm going to first I'll plug in 1 to the 3rd, then I'll plug in 2 to the 3rd, then I'll plug in 3 to the 3rd, right? Then I'm going to plug in the upper limit of 4 to the 3rd, and then I stop. Right? And that's all math that we could do pretty easily here, right? That's 1 plus 8 plus 27 plus 64. Right? And I'm not even going to resort to the calculator here. It looks like that's 8491 plus 8 is 100. So, in fact, you can do this in the TI calculator or using Desmos. So, but I would be careful that if you're going to use it, do the TI instructions. The textbook instructions are not what you want to do because it looks like it's based on an old operating system. So let's do this summation in both Desmos and with the graphing calculator. That was wrong. Yeah, let me change this to be at the bottom so we can see everything. So the first thing you need to find, where is this sigma notation in the calculator? Well, the sigma, turn on, is actually in a few different places. Remember, you can find anything in the catalog. If you go to the math menu and scroll to the bottom, there's the summation notation right there. And you can see where it gives you the chance to put in all those things that go around it. Or another place is if you do alpha window, there's a menu of like commonly used things like absolute value, summation, the log of any base. The 3 and the 4 are calculus things that we wouldn't use. But definitely number 2 is the sigma notation. So you can use X or you can use N, it doesn't matter. Looks like the N is on the log key. So I'm going to say alpha log 1, arrow up to the top to put a 70, and then put in the formula. And it has these parentheses here, so put everything inside of there, right? So 5 alpha log plus 3. And if that looks like the same thing, then hit enter. 12,635. I think that was the same one we just did on the couple slides ago. So that was using the graphing calculator. Now let's try to do with Desmos. Okay, so now we're going to use Desmos, and I can't really have both on the screen at the same time, so we'll just remember 5n plus 3, 1 to 70. All right, so let's go to that. Now the summation notation in Desmos is here. Go down to your keyboard, go to the functions, go to miscellaneous, right there is the sigma. And again, it looks pretty similar, right? So we said we're going to go from 1 to 70. And then in front of that, we put the formula for AN. I am going to use parentheses. You probably don't need it. 4n plus 3, enter. And something is wrong about that. 5n plus 3. So I should have made that a 5. And there's the same number, 12,635. So, you know, when you have to do a summation for any reason, you have technology to help you do that. And like I said, Desmos is not going to be available on the 9.5 week test, half of 9 week test, or the CSAs, but it'll be on the SOL. So let's try one more. I think this is going to be a U try. So try to do that with the calculator, or with Desmos, or with both. And it is going. Okay. So again, we're doing these with the calculator. Again, using this calculator, you find the sigma notation either under the math menu or alpha window. I'll use the math menu this time. So let's put an n alpha log equals 1 to 50. And we can put in alpha n squared minus n. And if that looks good, then you hit enter, and it looks like the answer is 41,650. And again, you could do with Desmos, just use the same thing. This time we're going to 50. This time we've got n squared minus n, 41,650. Same thing. So that is the end.